right, we're back. We're out here in the service bay here at the shop, and we're showing you the CDS 4.8 now. This is the direct drive system. This is in a Chevy. This is a 2018 van, and so CDS, as you know, is a direct drive. So this drive shaft here is what drives your blower and your pump. You'll see the pump is the same as the 575 we showed you. The blower is the same as the 575. So it's a 4007 Tut Hill blower and the 3.5 gallon per minute general pump. So the drive line, which is operated on a takeoff clutch, powered takeoff, CDS clutch drive system. The clutch is on the front of the engine. When you turn on your power or your ignition switch here with the van running, you can hear that clutch engage, and that's it. Once the clutch engages, it starts spinning that drive shaft. That's how the CDS operates off the van's engine. On the CDS, we have the ignition switch, what I just showed you, the key. You have your throttle control, low, medium, and high speed, which is electronically controlled, which I'll show you soon. You have your pump clutch. So if you have your pump clutch off, again, you can do water extraction without using your pump, and you'll just be using the blower to create vacuum. Your fresh water switch here is to turn on your transfer pump if you have a freshwater tank. So if you don't have a freshwater tank, then you're not going to use this switch. And you can see that he does have a freshwater tank in the back of this truck, a wheel well tank. I should mention that this is a local customer of ours, very good guy, Extreme Steam Cleaning here in Mukilteo, Washington. That's so kindly let us use his CDS for displaying today. We also have a pump out switch here. If the system is equipped with a pump out, which this one is, we have the our pump out, the HydraMaster pump out is the AWDS, automatic water disposal system, and that sits nicely back behind the waste tank there. You can see the CDS, all the wiring is in this wiring box, which it's hinged. So if you need to get in there for anything, it's easy to get to. Hour meter. The machine has 447 hours on it. On the instrument panel here, you have your pressure adjustment, your regulator valve. This is where you adjust your pressure here, your pressure gauge. This machine will do up to 1200 psi. And back up to the top, your blower lube port for lubricating your blower at the end of the day. Your chemical system controls. The CDS is a dual wand function machine. So you have the dual quick connects here for your solution, and also dual vacuum ports up top on the vacuum tank. Your incoming water quick connect is the big 660 quick connect, and this one has a hose connected to it already because it has the fresh water tank, and this is plumbed from the transfer pump, so you're utilizing the water inside the fresh water tank. If you don't have a fresh water tank, you'll have your garden hose fitting that comes with the machine. So this side screws on to the garden hose, and you'll notice there's a filter there. You want to check that daily, make sure that that's clean. So garden hose will connect to here if you're connecting to the building or the house, and you'll just connect there manually. But the convenience of having a freshwater tank is That's one less hose you have to run daily on every job. So you also have coolant flow valve here. On the CDS, we have two coolant heat exchangers. I showed you the tube and shell heat exchangers earlier on the 575. The CDS also uses the tube and shell heat exchangers, but they're a longer version. You want to show them those in there, Dennis?
Sure.
So what we do is we tap off on the van's engine coolant on the top radiator hose, and that'll come back from, we tee off into the top radiator hose, and it comes into this control valve, which I just showed you on the front, this two-way valve. So that's your hottest water coming from the van's engine, okay? Now the valve, if you have it open, so max control, max coolant, it's gonna flow through the valve and then into the heat exchanger. And there's two heat exchangers under here. So it'll run through one and it'll loop in onto the other side, come through on the top heat exchanger, and further heat your solution. And then on this hose, it's going to return back to the engine, to the engine water pump. So it's just one loop of coolant flow. So that's the main source of heat on the CDS is your coolant. So the coolant control valve, if it's open, as I mentioned, it's going to be flowing through the heat exchangers, okay? Now, if you turn the valve off, it's going to deadhead the coolant from the top radiator hose that I told you where the hottest water is coming in, and it's not going to have any coolant going through the heat exchangers. It'll just deadhead there. And the purpose of that is heat control. Now, I always say one of the best things about the CDS direct drive unit is that it doesn't have all the heat management controls. So like the electronic temperature controller I was showing you earlier, or all the components needed to manage the heat. So this, by not having all that, you have down on the CDS, you would use this valve. So again, if you wanted to have lower temperatures for upholstery or wool, you would turn that off, or you could put it somewhere in the middle and flow a certain amount of coolant through the heat exchangers. But more times than not, you'll just have this open for heat performance. So that's the coolant control valve. You also have your water box drain here. So this will drain your water box, which is handy. This is your water box here in between the seats, right up here. Water box. Okay. So when you hook up your water, this is going straight to the water box, your incoming water. And this is the drain for the water box, which can be used as a clean out, or fresh water for filling your chemical jug or whatnot, or draining your water box down to add coolant for freeze guarding, which we'll talk about later. And then the other control here is your automatic pump out discharge here. So it has a cap on it. When you're going to use that pump out, you take this cap off, and you hook up your garden hose here, and you run that to where you're going to be dumping your water. You want to say something?
It's just a discharge port.
Yep. Discharge port for your pump out. All right. So we talked about the coolant heat exchanger. So there is an additional heat exchanger on the CDS, which we call the salsa heat exchanger, or the blower exhaust heat exchanger. And that's this guy over here. Climb in here. So this is your salsa heat exchanger. So you can see the blower exhaust exits out of the bottom of the blower, runs through this hose,
enters the salsa heat exchanger, and this is a tube and fin heat exchanger, which I showed you earlier. And then it exhausts down through the floor to your external silencer underneath the truck. So after your hot water exits out of the coolant heat exchangers, the tube and shell, it'll enter the salsa heat exchanger and then out to your wand. So that's the heat controls. And then I was talking about not having all the components for the heat system. The only thing for heat management on the CDS is the, and we talked about earlier, thermal valves. So this thermal valve right here, see that? That is a 165-degree thermal valve. And again, that monitors the temperature in your water box here. So when this water box gets up to 165 degrees, that thermostat or thermal valve opens up, dumps water into the waste tank right here. So again, on your CDS, if you are having symptoms of your waste tank filling up too fast or faster than normal than you're used to, and you're not building heat like you normally do, then the first thing you want to check is if this thermal valve is dumping water into your waste tank all the time. So you can lift up the tank and look on the other side of this fitting, and if it's just constantly dumping in there, then that thermal valve needs to be replaced. Another way of checking that to make sure it's operating properly, because it is supposed to dump in there at 165 degrees, is you would put a thermometer inside the water box and watch that temperature to rise. So if it's dumping water into your waste tank and it's under 165 degrees, for if it's 140 degrees, let's say, and it's dumping, then it shouldn't be, and you would need to likely replace that thermal valve. So this is the only component as far as the heat management system on the CDS, is which is a big reason why I really like the CDS, is one less system that you really have to service all the time.
Simplicity, very much so.
Yeah, it's very simple. We're going to talk about probably one of the most important maintenance items on the CDS. We recommend every 500 hours that this drive line, all the Zerk fittings on the drive line and the 2 pillow block shafts on the jack shaft be lubricated. I'm going to show you the easiest way to do it. The front the U-joint on the front behind the clutch is the most important one because it sees extreme temperatures. So on the back of the clutch on these drive lines, you have two flexible U-joints. This one goes to the blower. It's the splined end here. And then this one would connect to the back of the clutch shaft. As you can see, this one doesn't have a yoke like this on it anymore. And the reason for that is it was failed to be lubricated properly at the right intervals, and it dried out, and then eventually it broke busted the U-joint and the whole yoke off of it. So what this person probably experienced was they went to turn on, they had their van running, they turned on the CDS, and the speed came up on the engine from the throttle control, but they didn't have any vacuum because this was busted off and not turning, spinning the vacuum or spinning the blower and the pump. So that's why this front lubricate U-joint is very important to be lubricated. We also recommend the lube, because this is under the hood. The grease that we use is the only grease that we recommend is this Mobile Delvac extreme high temperature grease. A tube of this comes with every CDS.
You can also pick it up at your local auto parts store.
That's correct.
Can I say one more thing, Louis?
Yeah.
The thing about this drive shaft is that this is under the hood, and even when you're not using the machine, you still have under hood ambient temperatures that are going to start to deplete the ability for this to stay lubricated. So lubricating this every 500 hours is extremely important.
Okay, so as far as the lubrication process, this is a grease gun. We have the high temperature mobile Delvac grease in this, and it's kind of red in color. Can you open that and show?
Yummy.
If you're kind of maroon red color, that's your high temperature grease. So if you get a fitting kind of swivel adjustment fitting like this is best. And oh, one other thing about the U-joints. So let me see that one there. The older style U-joints had the Zerk fitting right here in the center of the U-joint. And this is the front grease fitting has always been pretty hard to get to under the engine. So from up front, because this is covered by the end firewall, basically, it's hard to get in there, and it's a blind application if you're trying to do it from under the hood. But we changed the position of this grease fitting, and we put two Zerk fittings, which I'll show you in a second here, on the outside of the caps instead of on the actual U-joint on the center there. So it's easier to get to from any angle that the drive shaft is in. Correct. Okay. So here's how they are now. So we put the Zerk fittings on the outside caps, and see it's not on the center anymore. So you can see that we took the engine cover off. So normally when you're going to lubricate the driveline, you don't need to take the whole cover out. We just did that for viewing. But if you pull back the engine cover towards the power pack, that's going to expose your U-joint enough for you to visually see it and lubricate. So slide on this side here. Okay, so let me see. We're looking right in there. Right up here, you can see the U-joint. Okay, and I could spin it so I could get to the Zerks. There's the first one. So you can see that. So the important thing about lubricating these, let's do the back one first here, so you can see it better. Put that light, Dennis. All right. So when you're lubricating these Zerks, so you want to hit each one. So you want to make sure when you put your fitting on there, it clicks in. You can kind of hear it and feel it. So it clicks in, and what we want to see is the grease protrude out of the seals on this U-joint. And you can hear that sound of the grease coming through. I usually pump about 1 pump to two pumps in each Zerk fitting. And what you want to see is the black grease coming out, and you want to see the new grease coming out, because that's pushing out the old black grease. And then the contaminated grease, and you know that you've properly evacuated the old grease and you have the new good stuff in there. So you can see it coming through seals, and then you're good. And the other critical thing is wiping up all this mess, because once this thing starts spinning again, it's just going to start flinging grease everywhere. And if you don't have your cover on in here and you run this thing, it's going to fling all over the floor or the headboard. So you clean that out real good. And then the next step is going to be to hit all the Zerks. So the next one going forward is your spline here. Get that on there. same time. And I usually do 2 pumps in there, and you'll see some grease start coming through on the spline. And then again, make sure you wipe it up real good. And then the most important one, like we mentioned up front on the back of the clutch. And like I said, we recommend greasing these Zerks every 500 hours. And in hotter climates, like in the summertime, every 250 hours, because the temperatures get even hotter in hotter weather under the hood. And this is where the swivel adapter comes in handy under here. And you'll see this is the reason why we pull back the doghouse engine cover, is so that you can actually see the grease coming through the seal and not blindly lubricating the U-joint. Because a lot of people, if they're not, you can zoom out a little bit. So if you're not getting that click in on the Zerk fitting, and you can't see the grease coming through the seals, then you can think you're, or you could be mistaken in thinking you're shooting the grease into the Zerk fitting, but it's actually just building up around the Zerk. So that's why we like to visually see the grease, and that's why we pull the doghouse back. Again, after you lube those Zerks, you want to clean that grease off, because under the hood, especially, it's going to sling grease everywhere. And the next time you go to work on anything under the hood, it's going to be a mess. So there are 2 more Zerk fittings. So we have the 2, if you have the Zerk fittings on the outside caps, you have 2 on each U-joint. If they're the old style, like I showed you, on the middle of the U-joint, there will just be 3 on the driveline. But all current drivelines will have 2, 4, 6. 5. Math is bad today. Also, you'll have 2 more Zerks, as I mentioned, on the pillow block bearings for the jack shaft. And those are probably have to go to the other side with the camera to see these better. Oh, the light. So the front, this is the front pillow block bearing here. So this is where the our drive line connects to this jack shaft here, and that runs through both bearings to the back of the blower where our pulley is.
You can see the Zerk right there with the grease coming off of it.
Yep. Right there. So that one's on the bottom.
Yeah. And then there's another one that's in the very back. There's 2 of them. You're a tight bugger to get to. That's where this 90 comes in handy.
So we get that click in.
There you go.
All right. And you can
See where the grease gun's on there.
Yep. And in between the seals, you can see the grease shooting out of there as well.
Yep.
And the old grease leaving. All right.
That's the front one.
That's the front pillow block bearing.
Now the rear one, I'm not going to be able to get the camera on, I don't think. I'll do my best.
Let's see, the rear, right here, probably come right from the back, Dennis. Your light's right on it. And as you can see, we have the seats, the passenger and driver seat out of the CDS. When it comes to service and maintenance, if you take the seats out, or even just the passenger seat normally, it really opens everything up and makes everything easy to service on the CDS. Okay. So the rear, you'll notice on the rear pillow block bearing, the Zerk is on the top, and on the front one, it's opposite, it's on the bottom. So So that's 1, 2, 3, 4, 5, 6, 7 total Zerk fittings that we need to hit.
For the newer machines, yes, sir.
So we hit all 7. This CDS is now properly greased.
Very good, Louis.
I'm on the passenger side here. Everything is accessible from the passenger side for the most part. If you take the seat out at time of oil change and service, it's very simple. So you can see on the blower here, on the passenger side, we have the blower sight glass. Center level is full. And then the rear sight glass, center level. And then the sight glass for the pump is on the front side here, on the center. And also we have our oil drain hoses on the pump that extend out outside of the truck so that you can easily put a drain pan on the floor. Same with the blower hoses. So you can actually do all 3 out of the side here. Couple of things you'll notice on the CDS, can't tell where my camera is. We do have, so some of you might say, what's this filter here for? What it's for is it goes down, you'll see if it goes down underneath the power pack here.
And underneath there, what we have is we have a inertia sensor. They call it a yaw sensor. And we have a special developed cover that we've put on it, made out of stainless steel, that seals it in place, keeping it away from moisture and vibration. And what we do is we take the airflow from the blower over there on that elbow right there. You can see there's another hose attached to that. Go down to the cover underneath the blower, and then we pull fresh air through it continuously to cool it and to keep it at a normal working temperature.
So this the air, it's sucking airflow from here. This is the intake. So you want to make sure that this is clean here so that it can pull fresh air through that cover and keep the sensor cool. So that's what these 2 gray hoses are on the CDS. As we mentioned, the van has to be running for the CDS to operate. So I'm gonna start this up, and I'm gonna show you the way the electronic throttle system works. So this is the actual electronic throttle controller. Okay, this one is a ETM 68A. ETM is electronic throttle module. So the way this works is it interfaces with the vehicle's computer, and it does that through a harness like this. This side of the harness will plug into your OBD2 data link. So if you're familiar with OBD2 scanners for onboard diagnostics, OBD2, it plugs into that port, and then these wires hook up to the CAN system terminals here. And then you'll have a power and a ground through the vehicle. And then you have RPM 1, 2, and 3, which are your 3 speed settings. And the cool thing about these controllers is, so what this does is when all the safety requirements are met, they call them chassis ready conditions on the vehicle to safely bring, because we need to bring up the speed of the van's engine to turn the blower at the speed that we want to. So the way we do that is through electronic control. So the chassis ready conditions, there has to be safeties met before the van's computer will allow you to do that. Okay. And there's some trouble lights on the side here, these LED lights that and it tells you what each one is here on the side. And the main 5 that we're concerned about here are from the top 5, starting from the top down 5. So there's bus, gear, PK brake, SR brake, and V speed. So just go through those real quick. The bus indicates the communication between this controller and the van's computer. The gear, that's the gear selector. So it has to be in park, basically. As the vehicle has to say that it's in park before it'll safely elevate the idle. The PK brake stands for parking brake. So your emergency brake has to be set in order for the RPMs to elevate. SR brake is service brake, and that's your brake pedal. So nobody can be pushing on the brake pedal in order for the RPMs to increase. And V speed, which is vehicle speed, that means that the vehicle cannot be moving, or the computer has to sense that the speed sensor is not, the van is moving at 0 miles per hour. So all those things need to be are required before the RPMs will elevate. Now these lights will be lit up red when you have the van running and the CDS is on. Otherwise, these will be off unless the van is on, running, and the CDS is on. So I'm going to display kind of how this works here for you. So we're going to start the van. He switches off over there. Yeah. Got it, Justin? Key switch off? Okay. So we'll start the van. Where's that light? Okay. So underneath the dash here, the driver's side, you'll find the controller here. Okay. Now that we put that up with Velcro so that you can pull it down and easily access it. So there's Velcro on the back side of it. You'll see all the wires hooked up to it that I explained. And there's no lights on, okay? So go ahead and turn on the CDS. So we have the van running. Okay, so Dennis is gonna go ahead and turn it up. Ready? Clear? That's by 4 right now. All right, so you can see the lights are lighting up, and I have lights flashing here. Okay? And I'm concerned about the top 5 down, remember? Now, so I'm looking at which light is flashing, and it's the parking brake. And you can see here, my parking brake is not set. So if I go ahead and set the parking brake, you're gonna see that light stop flashing, go solid, and then the RPMs are gonna elevate. And now it's solid, my speed came up. If I release the parking brake again, it's now blinking again and it drops to an idle. Same thing so I'll set this. If I step on the brake pedal, see the SR brake is now flashing and my RPMs decreased again. Let go of the brake pedal, it's gonna pick back up. So that's an example of how the throttle control works. We saw that the PK brake and the parking brake and the service brake were both, we released the brake and stepped on the brake, and that caused our RPM to drop. So in a cleaning situation, if you were cleaning in the house and you lost vacuum and pressure, and first thing you want to do is go out to the van and see if any of these lights are flashing on you. Normally, it's just gonna, if if one of these safeties is violated, it's just going to drop the engine speed down to an idle. All right, so that's the throttle control. One more thing about that is the harness I was saying that connects the throttle module to the van's computer. From the vendor that we order these from, they send a harness that comes with the controller. That's this one. It just has 2 wires on the end of it. HydraMaster we started making our own harness for 2 reasons. We found that we found a better ground through the computer. So we added a pin in the system for grounding the controller through the computer versus grounding it to the chassis. The second reason why we made our own harness was, you'll notice that this one just plugs in straight to the OBD OBD2 connector, which means you have to have it plugged in there all the time. So if a mechanic or anybody needs to plug in a scan tool, they have to unplug this, which they usually don't plug it back in, and then you get your van back from being serviced and it's not working right. So if that's happening and you don't have this harness and you have this one that needs to be plugged in all the time, make sure you plug this back in. So what we did to eliminate that having to have it plugged in all the time was put a piggyback plug in our harness, which means we replaced the original dowling port right there, and then plug in direct to the original one here, and that leaves this open so that you don't have to have this plugged in there all the time. Mechanic can get in there and put a scan tool on there and whatnot. So this is the style harness that we use now.
All right, the main power for the CDS to the front dash is tapping off of this the battery lug here underneath this driver's seat, and it runs through an inline fuse here, a 30 amp inline fuse. Take that out and show you. So this is the main fuse for the CDS. It's underneath the driver's seat. So if you have no power up to your front dash on your CDS panel there, you want to go on under and check that fuse there. So that's providing power to the main dash, and we'll go around to the other side and show you another safety. All right, so the main power from that fuse that I was just showing you then comes in to a circuit breaker, which is here on the front of your machine, this reset button, okay? And then it goes into the ignition switch. So also, if this circuit breaker, see that little white knob there, if that pops out, then the circuit breaker is tripped. So we won't have any power, nothing's gonna light up here. So you'll check if this is tripped, push it back in. If it continues to trip, then something is probably shorting out and has to be addressed. And then we would also, the next step would be to check the fuse underneath the seat cushion. What else you got for troubleshooting? Oh, sorry. One other feature I wanted to explain on the CDS also is the ability to close the doors on the CDS, because on the slide-in units that have their own engine, the engine has to breathe properly and be cool. So you have to have the doors open for airflow in the van to provide fresh air for the engine, for the exhaust properly. On the direct drive units, CDS and X drive, close the doors, which is very good for security because the engine does need to be running to operate. Close the doors and lock them. And it also is quiets down the machine a lot. So if you do a lot of nighttime cleaning or high noise ordinance, high end neighborhoods that don't like a lot of noise in their neighborhood, you can close the doors. It's really quiet. The way we can do that to close the doors all the way with our hoses running from the machine is a hose pass through here. So part of your CDS installation, this comes standard. You drill a hole through the step, 4.5 inch hole, and you run your hoses through the step. So, and the easiest way to run them is run them back under the short lead through the bottom and up, connecting to your machine. And then you can close the doors.
See those tubes around the outer diameter of that heat exchanger? This is the tube and shell heat exchanger, the outer shell and the inner tubes. You can see where the pressure from the ice has taken and crushed those tubes. Okay, and that's what happens. And this will expand the ends of the heat exchangers out and create a situation where the heat exchanger is going to leak either internally or externally. In order to prevent that, we always recommend using a concentrated antifreeze. All right. Now, there's other products on the market people have tried, but there's no way of really telling what your dilution ratio is. With this, you can get a manometer and you can actually check the actual level of freeze protection. Okay. So right on the same aisle you buy the antifreeze, you'll be able to find a manometer, which is going to tell you what your level of freeze protection is going to be. We have a freeze guard kit that comes with most machines. All right. And that's going to be one of these little adapters. This little adapter right here essentially is going to screw into your garden hose adapter. So now you've got two adapters that you've threaded together. And what we're going to do is we're going to take a piece of solution line with a male-female end on it. And you're going to take the female end and snap it in place and plug it onto the inlet water connect. Then you're going to take the other end of this and plug it onto one of the solution lines. You've just created what we call a closed loop. Okay. Now what you're going to do is you're going to drain the water box down halfway and take 1 gallon to 1.5 gallons of concentrated antifreeze, and you're going to pour it into the round lid on top of the water box. This is to freeze guard your heat exchangers and your pump and all of the other components, your regulator. So what you'll do is you'll then pour a concentrated gallon of antifreeze into your water box after you drained it. Then you will then start the machine and allow it to recirculate. It doesn't matter what pressure you set it at, it's just going to recirculate. You'll have no pressure on the gauge because it's coming out free flow and back in free flow into the water box.
Or in order to have pressure, you have to turn your pump clutch on there. First one.
Right now it says
Get your pump out.
pump, sorry, 1 mile. Right.
Yeah.
So by pushing the wrong button, you don't start it. So push the right button next time. I'm just one of those guys. All right. So what we're going to do next is you're going to have 2 other areas that you're going to want to take consideration in on freeze guarding these things. And when you do that, the gauge is always one of the first things to tell you if a machine's been frozen by it being spiked. Okay. So what you want to do is once you do start recirculating the antifreeze through the system, take a small wrench and open the fitting at the back of the gauge where the hose attaches to it till you get some antifreeze spitting out of the back of it, and then retighten it. Because that's dead end, that's a dead end hose. So antifreeze isn't going to flow through it unless you open that up just a little tiny bit and crack that fitting on the back of the gauge to allow some antifreeze to go up the hose and stay there. Then you close it. Last but not least is the chemical system, because we have a last step chemical system on this machine that also is going to have some solution in it. So what you're going to do is, this is the easiest way for me to tell you to do this, is to take this acorn screen out of the jug, and under vacuum load, take this and block off your recovery tank and block it off and turn it to prime. When you turn it to prime, it sucks all the solution out of the system and dumps it into the recovery tank.
Just pulls it, just blows out the system, sucks it all
Exactly.
out.
It just essentially evacuates it.
Evacuate all the liquid.
Do that until you see no more moisture drooling through your flow meter, and you'll have that whole system evacuated. Once
Okay.
you're done there, go ahead and disconnect your lines. Put your lid back on. And if you want to freeze guard any of your tools, now is the time to do it. Because you can take your solution lines and hook it up to your reel and run antifreeze through your tools. They freeze guard those if you're leaving those in the truck overnight. So real quick, that's just kind of a 1, 2, 3. There are written procedures in the manual. They kind of vary from machine to machine, but there is an adapter for a freeze guard. It just adapts to your garden
Shows that
hose.
adapter.
Essentially, it's a garden hose fitting with a female end with a male end on it. Part number 078058.
And you can use that for descaling the system too, right?
Correct. You just essentially do the same thing we just did, but instead of using antifreeze, you'd pour descaler in the tank and just recirculate it through the machine. And then
Yeah.
once you're done, you'd have to open flush it depending on what you have. Now the pilot first is a maintenance descaler. It's called TM descaler. It's a HydraMaster product. This is a maintenance descaler. So you take a gallon of this, that goes into the water box. You basically allow to recirculate the machine, shut the machine off, walk away, and let it sit overnight. Not the next day. If you have any buildup in the machine, turn the buildup right blue. That's how it used to work. So I know this does permanently does turn blue. Basically, then it just flushes out. It's a very soft, cleansing product. If you have a large part water buildup, so if you're living in like the Ohio Valley or something, you're gonna need an acid-based descaler for the acid. Eventually, they have buildup inside the machine. We don't have an acid-based truck mount descaler, but we have a product called Clearwater Rinse, which is an acid fiber rinse. All right. So a gallon of this in the water box, recirculating it through the machine like we did with the antifreeze. And then you'll just shut it off and let it sit 10 minutes. Run it 10 minutes, dwell it 10 minutes, and then flush it out thoroughly. Now this is going to break stuff free, and it's going to come out in deposits of chunks. In order to get the machine clean internally, what you're going to want to do is you're going to want to most likely open flow one of these quick connects real quick. What I mean by that is I essentially just stick an open flow. I take a quick connect end off of one of these and just open flow it, because you're going to stick all that stuff through all your hoses if you don't. So you want to open flow the quick connect when you're done, just so it gets all the chip formations that you flushed out of the machine instead of just built up behind the quick connect. A lot of times that requires pulling the quick connect off, depending on how much buildup you had in your machine. So that's a pretty quick once over on descaling and doing a quick freeze guard. So heaters are kind of I've heard people use hot water bottles, heaters. I had a guy try and use an electric blanket one time. The best way to use it is to use antifreeze. Don't use an RV antifreeze, and don't use a washer fluid. All right, those dilute too quickly, and they don't have quite the level of protection. And there's no way to check the level of protection in those things. Once you put it in a machine that already has water in it, you're diluting it, and you're going to lose that protection depending on the level of how cold it's going to get outside.
Yeah, and it's a real good time right now to talk about freeze guarding, since most of the country is getting really cold.
Yeah.
So heat exchangers are the most expensive component to replace when freezing a unit. Sure some of you have learned that the hard way. All right.
What else we got, Louis?
Cover descaling. Is there any questions on there for freeze guarding or descaling? Let's talk about some of the reasons why you need to descale. Hard water would be the biggest reason. So calcium buildup within the system. If you have water in your water municipal higher than 3 grains per gallon, then it's recommended to use a water softener to treat the fresh water going into the machine. So water softeners come and you check with your local distributor on different models and types of water softeners that you can purchase for your system. But yeah, quality of the water is important. Speaking of that, one thing we didn't cover is where the recirculation orifice is on the CDS. So let's see if we can get a look at that.
All right, the recirculation orifice is in the CDS because of gauge accuracy. Once you took your hand off the tool without the orifice in place, the gauge would drop to 0. So with the gauge sending unit in line with the orifice, we are constantly allowing the solution to run past the gauge to give us the proper flow to give us an accurate reading on the gauge.
So you can see this style of orifice or housing is like what we showed you earlier on the Boxer 318. It has a plate orifice inside there. It's located here at this behind this cross manifold there. So you would just put a wrench on this fitting and this one and loosen it up. And it also has the inline filter inside there that you want to clean out.
All right, so let's talk about the chemical system on the HydraMaster machines. Because the chemical system has a 3-way valve and then a select meter, but there are also other parts of the system that we really want to kind of talk about. Now, the chemical pump is on the other side of this, but essentially we have a high pressure pump driving a chemical pump, okay? The high pressure pump and the chemical pump are working together. So when you set your pressure at any rated pressure here, say at 300, that's what the pump's putting out. That's what also the chemical pump will see. So essentially the chemical pump is a slave pump to the high pressure pump. So what we're doing is we're taking the high pressure water from the machine, from the pump, and putting it into the regulator, which is the knob you turn the pressure up and down with. That's the first pathway it goes, and then it splits. One side runs through the high pressure heat exchangers and back to the front of the machine. And then the other side is going to branch off and recirculate back to the water box, low pressure. And I call that the bypass side of the pump. Essentially, we have to do 2 things because in order to get proper injection on the high pressure side of the chemical system, you have to have a pressure differential, okay? So if you have 2 perpetual chemical streams, or 2 perpetual streams of pressure, one coming out of the high pressure pump, going through the heat exchangers at 300, and then the other 300 PSI stream coming out of the chemical pump, you have too much resistance. You can't create a draw. So what we have is we have what we refer to as a chemical differential check valve. Can you get it? Can you get in here to see that?
Yeah, let's see if I can get in there.
I'll go grab it.
Yeah.
All right.
So on the CDS, the differential check valve is located right behind the quick connect, the high pressure manifold. Let's see, kind of hard to see here. It's this guy, hex-shaped brass 2-piece body. So,
And here's a good
Looks like
example of it right here. And what this has is a chemical differential check valve, is a 1-way check valve. And we're bringing the high pressure water from the heat exchangers into one end of it. And it goes through it, but on the innards of this, we have a spring and a check ball. Okay. And what that's doing is giving us resistance. So this is considered a 100 PSI check valve. We use a small spring and a small check ball on the interior of it.
bring that to the camera. So you can see it better. Here. Closer.
Oh, closer. I'm sorry. I can't see what I'm looking at. So anyway, the check ball is going into a seat, and that seat gives us the ability to create back pressure. There's a spring on top of the seat, and then there's this other half of the body, and they screw together, and the solution is going to flow through this. And what it does is it creates a back pressure on the outcoming water, a drop of 100 psi, which gives us the ability to inject the chemical stream into the front of this check valve, and that gives us the draw that we're looking for to go to the tool. One more thing it also does is it also gives us the ability to have no chemical backflowing through the piece of equipment. All right, so if you have chemical going through this check valve because there's some piece of debris or this spring has fatigue or something, then it's going to allow chemical to flow back through, which means your flow meter is going to be bouncing all the time without your hand on the tool. So if you have that going on, you've got one of two things either going on. You either have a diaphragm with a hole in it, or you have a differential check valve with debris in it, or something else going on. So you'd have to take it apart and see exactly what's happening on the interior of it that's holding it open, because this thing, it keeps chemical from being digested back into the heat exchangers, and it also gives us that injection differential that we're looking for the chemical pump.
Last step, chemical injection. So chemical does not flow through the system. Your cleaning solution does not flow through your pumps and your heat exchangers. So it keeps them clean and don't get plugged up. Before, what did you have before chemical pumps?
You had pre-injection, which we would inject chemical into the heat exchangers, and it would end up creating a lot of chemical solidification. And chemical solidification would give us a problem with plugged up heat exchangers and debris in the check valves and that kind of stuff.
All right.